Malaysian 370, contact Ho Chi Minh 120.9. Good night.
Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
Give us the power now.
I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds."
Welcome, everybody, to the live stream, and thank you for joining me. I am your host, Ashton Forbes. Guys, tonight we are talking about magnetic orbs, and we are talking about wormholes. Guys, you know I don't like a lot of filler, so let's just get straight to it. But before we do that, I want to thank you all for being here. It's been an incredible journey. This is honestly a true life mystery unraveling in real time, and I think that's why everybody is so interested in it. What we're talking about is the MH370 videos. If you're watching the live stream right now, you are seeing the Gorgon Stair wide area motion imagery. This is literally Malaysian Airlines Flight 370 being recorded by an Air Force asset, which is called Gorgon Stair. It's wide area motion imagery. That's why it looks like a computer screen, because it's literally a computer screen. Because there literally is relaying off satellite NROL-22. The Newsweek debunk gets it wrong right down there. That says NROL-22. And their coordinates, this is the Nicobar Islands. This is about 20 minutes away from the last public radar plot of Malaysian Airlines. The last radar plot by Malaysian military radar that was released to the public. We're seeing 3 orbs, right, spinning around the plane. They're spinning around the plane vertically here. This is going to be very important later on. And then they kind of slow down near the end. And then the plane's just gone. Plane's just gone. And then somebody moves the screen around, and then they go to the top right off the screen, and then the window goes black. Window's black. We're looking at a black window, still recording. Somebody leaked this footage. Somebody leaked this footage to us. And then we have our second video. If one video wasn't enough, everybody always asks for 2 videos. They say, okay, show me another video from a different angle with another asset. Okay, here you go. Here you go. Right away, we can tell we're looking at an MQ-9 Reaper drone. You can just see the nose of the drone, extremely distinctive here. We can tell we're under hard point number 5. So this is a Lightning G4 targeting pod. Now, the big rub with this video, the reason why this video is so big is the temperature. The temperature. All of this comes back to temperature, because temperature is energy. Heat is energy. And we are talking about unified theories of electricity and energy. So temperature becomes extremely significant when we are talking about building systems that are either near equilibrium or manipulating like the fabric of space-time. We're creating perfectly efficient systems. So right off the bat, these orbs being green is pretty interesting. They're fully green. They're not white hot. They're not red hot. They're almost ambient temperature. I wanted to show this in slow motion here, but let's just go back to it. And we can see they kind of change. They change a little bit. They're changing. This is going to be really, really important later on in this stream. We can see the heat signatures in the orbs kind of morph a little bit. It's not just solid green anymore. Now it's like partially blue and partially green. Almost like they've synced up and they're working in rotation with one another. And this aligns with them moving in this perfect triangular formation. What I'm going to show you guys tonight is that the movements of those heat signatures that you see in the orbs, is 100% proven to be real via the laws of physics. 100% proven to be real via the laws of physics. Nobody could have faked it because even a computer model probably couldn't have faked it back then. That's essentially, I'm going to show you peer-reviewed science that will be able to prove this here in a minute. But before we do that, I'm trying to decide the order we're going to do this. I think we're going to look at the magnetic wormhole portion of it first. Now, I want to point out, guys, when we watch these videos, there are things we can glean. You know, I think back to TV shows, movies, anime, when the villain is like super powerful. A lot of people have this mentality of, oh, it's just magic. They're magical. They're invincible. Like how people think, oh, how could a UFO crash? How could a UFO crash? It must be so powerful it would have to be invincible. Maybe it's really fragile. Everything has a weakness. That's why I like the smart animes, the smart TV shows. They're the ones that are like, they look at the situation and they don't just assume it's all powerful. The hero will go, what are the limitations? How does that work? How can I exploit that? And when I look at the MH370 videos, that's the question I ask myself. I say, wait, how does this actually work? How are they actually pulling this off? What is required to make a Boeing 777 teleport out of the sky? And we can glean information from these videos. They're in a perfect equilateral triangle, literally perfect equilateral triangle, not just like kind of close, perfect. We can see the heat signatures in the orbs. What are the heat signatures in the orbs? They most likely reflect the electrons, which are hotter than the ions in a plasma. We can also tell we're looking at a ball of plasma. You might say, Ashton, how can you tell you're looking at a ball of plasma here? We can basically see through it. At some points, when it goes over the plane, you're basically looking right through it. So it must be partially transparent. And what's transparent? Not much. This means we're looking at the magnetic field lines. We're looking at the magnetic field lines that are confining the plasma. That's what we're looking at here. Now, this doesn't tell us that there's something inside of them or not. Personally, I'm of the opinion that there is something inside of these orbs. There must be. Why? Because we see them lock into the plane. They lock onto the plane. They, in several points, they seem to move where they have some sort of input. Now, if you have an input, you need a brain. You need something, a receiver, to receive that input. So there must be something inside of the orbs. It can't just be nothing inside of them. Has to be something in there that is able to communicate with the outside world. Now, the other thing we can figure out is near the end here. They changed their orientation. Clearly, they are now vertical on the plane. They're vertical on the plane, not just like a little bit vertical. They're exactly vertical on the plane. This has purpose as well. And then the last bit is the biggest clue of all. Now look at this. They are perfectly vertical on this plane, and then they converge. They don't just converge, but they like change modes right here. They're going to change modes right there. They change modes, and then they converge on the plane. And when they converge on the plane, they completely enshroud it. They completely enshroud the plane. Whatever happens, we don't see the plane anymore, except for in one frame, we can see the reflection of the tail of the plane. In this frame, we can see the reflection of the tail of the plane sticking out of the back. These are all clues. Now, the last clue is the color. It's black. It's black. It's non-thermal. How can this be non-thermal? How can that not be white hot? Everything we've been taught to believe should say that this should be a white hot explosion that we're looking at here. But it's not. It's black. And this would indicate some sort of negative entropy situation. Neg entropy, a cooling effect, or a release of X-ray photons, something that's outside of the thermal spectrum. And that is the biggest clue of all. That's why they didn't want anyone to believe those videos were real. That's what they were terrified of. That's probably why the debunkers also attacked the Zap. You have 2 videos, and out of 2 videos, they decide to attack one frame. They attack one frame where we're seeing a wormhole happen. Yeah, they want you to think that's really fake. They need you to think that's fake, because if you start to realize that that's real, you're going to really start to wonder what they've been hiding. So, magnetic wormhole. I want to point out, if you Google magnetic wormhole, you get one and only one response. It's this scientific paper and a bunch of articles about it. A bunch of articles just about this scientific paper. That's what you get. And it's crazy if you just read what, again, the most powerful thing you can do is just read. Just read the scientific papers. It just says it right in there, unambiguously, says it unambiguously. Wormholes are fascinating cosmological objects that can connect 2 distant regions of the universe. Because of their intriguing nature, constructing a wormhole in a lab seems to be a formidable task. A theoretical proposal by Greenleaf et al. Presented a strategy to build a wormhole for electromagnetic waves. Based on metamaterials, it could allow electromagnetic wave propagation between 2 points in space through an invisible tunnel. However, an actual realization has not been possible until now. I'm going to remind you, 2015. This scientific paper is from 2015. Here we construct and experimentally demonstrate a magnetostatic wormhole. Using the magnetic metamaterials and metasurfaces, our wormhole transfers the magnetic field from one point in space to another through a path that is magnetically undetectable. We experimentally show that that the magnetic field from a source at one end of the wormhole appears at the other end as an isolated magnetic monopolar field, creating the illusion of a magnetic field propagating through a tunnel outside the 3D space. Practical applications and results can be envisioned, including medical techniques based on magnetism. Holy smokes, chat. Well, we're watching 3 clearly electromagnetic plasma orbs enshroud an airplane, and then it disappears straight out of the sky just like magic. And here we have a scientific paper that is saying, in no uncertain terms, they have created not just a theoretical simulation, but an actual demonstration experiment that shows the magnetic field going out of one side and through the other. Now, why is this huge? This is huge because essentially, if we have something on the inside of that magnetic field that's got like a little bubble, where's that going to go? Where's that going to go? If we make a little bubble and we put something inside that little bubble in this experiment that we are just looking at right here, where is it going to teleport along with the magnetic fields? I mean, I think that the paper authors are making that implication. That's what I think that they're saying here. Now, let me read a little bit more of this. Large amounts of negative gravitational energy would be required, making this impossible with present technology. Now, such an object, though, could allow electromagnetic wave propagation between 2 points in space and time through this invisible tunnel. It would use bulk metamaterials with complicated permeability and permittivity parameters. Changing the permittivity of space-time, remember? Remember, the theory of zero-point energy is that you can change the permittivity of space-time itself. Now, what this paper is saying is that they are criticizing another paper. They're basically saying Jack Sarfati says that you need metamaterials to make your UFOs fly around. These guys are going, no, we don't. There might be other ways to do it. They're saying that, yes, the theory of changing the permittivity and permeability does change the speed of light, and therefore does allow for teleportation, faster than light relativistic travel. But they're saying we don't need a metamaterial to do it. So they're saying that this would effectively change the topology. When people say topology, they mean the shape. It would change the shape of space-time. since it would make electromagnetic waves propagate as if they were propagated in 3D space with an invisible tunnel connecting two distant regions. An alternative theoretical proposal based on plasmonics was presented in reference 11. Not for a full 3D electromagnetic wormhole, but a 2D analog. This is interesting for several points. One, they're talking about using plasma to create a wormhole. Plasma. And they're also saying to do it in two-dimensionally. Now, this is interesting because one of the cheapest, the lowest energy cost wormholes is a two-dimensional flat surface. And we're looking at 3 triangle orbs, probably in some sort of polyhedral configuration, teleporting a plane. Okay. However, building an actual 3D electromagnetic wormhole following the strategy in reference 3 is very difficult in practice. Among other technical difficulties, it requires cloaking a 3D object like the bulk of the wormhole from electromagnetic waves, and this has not been achieved. You know what? I'm going to go ahead and beg to differ with the authors and say I think they have figured out how to cloak a three-dimensional object with some orbs. In fact, there it is right there. There it is right there. Okay. In this work, we construct a 3D wormhole for magnetostatic fields. It will allow the passage of magnetic fields between distant regions while the region of propagation remains magnetically invisible. Although inspired by the theoretical proposal of Greenleaf, we do not design our wormhole based on transformational optics. Instead, we take advantage of the possibilities that magnetic metamaterials offer for shaping static magnetic fields. Where's the part? Okay, yeah. Now, what they say... Oh, yeah, this is pretty interesting. Where's the spiral part? Let's just read this first. The first property to be satisfied is to magnetically decouple a given volume from the surrounding 3D space. The volume enclosed by a superconducting shell has this property. We consider here a spherical superconducting shell. A second property is that the whole resulting wormhole cannot be magnetically detectable from the exterior. That part I'm not sure about. I've been wondering about that part. The superconducting spherical shell would distort an applied field and thus be detectable. A cylindrical magnetic cloak was made consisting of a superconducting layer surrounded by a magnetic layer. Similar bilayer structures have been recently applied. So basically saying that we can make a superconducting cloak. Oh, I'm not sharing the screen. They're saying we can make a superconducting cloak around an object and make it disappear. Now, immediately I think of the Philadelphia experiment. Philadelphia experiment, this is literally what they were trying to do in the Philadelphia experiment. They were trying to cloak a battlecruiser, and then the lore goes that it teleported. Yes, because if you shield an object from all the electromagnetic fields, you are decoupling it from space and time. Do you guys get it? Why is that a thing? Because we're in a medium. We're in a medium. If you create a superconducting shell, you have decoupled yourself from all the 0-point energy around it. You've created a new universe. Do you get it, guys? That's what a wormhole is. Now, is your new universe a bizarro dimension? Maybe you can create your own dimension. You can create your own universe. It's still just space and time. This is also why you have people like Hal Puthoff saying that there are UFOs where you go inside of them and it's bigger on the inside than it looks like on the outside. Same exact concept. You can actually just manipulate space and time, and we can make a bubble of space and time. So guys, when people ask, how are they producing the wormhole? Simplest answer is they are cutting out space and time with a superconducting shell. Remember, superconductive harmonic orbs. The orbs are superconductive. Once the plasma reaches a certain density, it becomes superconductive. According to, I think it's Miley and several others have made that claim. So they can create a superconductive plasma shell by crashing our orbs together. That's what we've so far gleaned. Don't worry, more is coming. Okay. And then the radius matters. Now, the other thing that we have is we have the orbs are around the plane, and they're around the plane at a certain distance, and then they collapse. They collapse on the plane as well. Let's remember that for later on when we review the next scientific thing. Okay, and then it also mentions the permittivity here. So one of the things, too, is that basically the condition for this to happen is that the superconducting layer of outer radius 2 surrounded by the ferromagnetic layer or inner outer radius 3 exactly cloaks a uniform applied magnetic field if the permeability of the ferromagnetic layer is this equation here, which is the vacuum permittivity plus a bunch of numbers. So basically, there's an equation here that tells you how do we cloak an object? Well, we need to satisfy this equation right here. Satisfy that equation. And of course, it has to do with changing the permittivity of space-time. Permeability, permittivity. Where's the part about the spiral? There. Okay. This part is pretty interesting. A final requirement for the wormhole is that magnetic fields have to propagate through its interior. Magnetic fields naturally decay with distance, typically as a magnetic dipole. In reference 25, a general strategy for transferring magnetic field long distances was developed. There, a magnetic hose consisting of a ferromagnetic tube surrounded by a superconductor was employed. Here we use an alternative option, mainly a thin ferromagnetic sheet wound into a spiral. This scheme was also theoretically shown to yield good field transfer at a distance. Here, it is experimentally confirmed. So for some reason, spiral shapes increase transfer distance in your teleportation, in magnetic teleportation. Do we have any spirals? You guys, do spiral shapes sound familiar to you guys? Oh, yes, we were just watching those orbs spin around the plane in a spiral. Now I can imagine that there are little tendrils connected to those orbs. Now, where is that plane going, guys? Oh, they're spinning around these tendrils back that way. They're spinning these tendrils around, and then they're going to snap it, and that plane is just going to teleport. Literally the rubber band analogy. That's what they're doing. They're winding it up, and then pop. We don't see it because it's magnetically invisible, just like it says in that scientific paper. The tunnel is invisible. We can't detect the tunnel, but it's there. It's there. Now, again, we're just using the information available to us in the videos. No secret information. There is definitely papers about this stuff on secret classified networks that we don't have access to. Guaranteed. We have to figure it out. So right there was a huge clue. This scientific paper is big because this isn't just theory. They have a literal apparatus they've set up to show this. Now, here's the other part. They talk about using pairs of Helmholtz coils. Helmholtz coil is a ring. Helmholtz coil is a ring, guys. And this is part of the reason why I thought maybe there's 3 orbs on the other side as well. Maybe there are 3 orbs on the other side, and they're like spinning in counterclockwise like this. And then they all converge together, and then boom, plane snaps to the other location. Okay. I do want to show something else on this. I think that's pretty much enough. Yeah, okay. So let me show this. So I clicked on that link when it talked about the plasma. This is the link when it talks about the plasma. Invisible waveguides on metal plates for plasmonic analogs of electromagnetic wormholes. October 2014. Interesting. We introduced 2 types of toroidal metamaterials, which are invisible to surface plasmon polaritons, SPPs, propagating on a metal surface. The former is a toroidal handle body bridging remote holes on the metal surface. It works as a kind of plasmonic counterpart of electromagnetic wormholes. Hold on. Where is it? There it is. Yeah, I'm going to go ahead and say that this experiment sounds really relevant to what we've been discussing. Really relevant. You know what? My favorite part is they have pictures. They have literal pictures because people like me, I just want to see the photos. I just want to see the pictures. Show me what it looks like. Oh, yep. That's a wormhole. That's a wormhole. Show me some more. Oh, look, toroidal shapes that we're making. Oh, look at these toroidal shapes that we're making to produce our wormholes. Wow. And then my favorite is this one. No, which one? There's more. Hold on. Where are the good ones? This one. Look at the boxes number 2 and then the one on the 6. The fields are not even disrupted. It's like the wormhole's not even there. You can't even detect it, right? So when we ask the question, you see these right here? We say, oh, the plane is disappearing, but the sky in the background is basically untouched. That's what this is representing here, is that we can make this wormhole and the background fields are basically untouched. This is like tethering, like stitching together 2 points in space and time invisibly. It's quite literally stitching together 2 invisible points in space and time. That's what we're talking about with a wormhole. So when people come at me and say, Ashton, where did the plane go? Guys, it didn't go to the planet. It didn't go to Zeta Reticuli. It didn't go to the Andromeda Galaxy. It didn't go to the Xenu dimension. It just went somewhere else on Earth. This technology is not unlimited. It has limitations, and the limitations seem to be it can't go infinitely far, and it needs to be point to point. They can't just shoot it in a random direction, although maybe they can, but they don't know where it's going to show up. And we found some pieces of the plane. So this plane stayed on Earth. The phones were still ringing. Again, this plane was on Earth somewhere. So where did they shoot it? Based on the right-hand rule, just simple electromagnetic theory, that plane went backwards. It went backwards. It went backwards to the west. Now, we looked at wormholes. Thank you very much for your donations. Appreciate it. Thank you guys for following along in the chat here. Now, we're going to take a look at a video that was from the APE 2022 by Charles Chase. Basically, we found the mother lode. And not enough of you guys have watched this video. Oops. Because I'm looking here and I'm still seeing only 273 views on this. 273 views. For the people who are wondering, who is Charles Chase? Charles Chase is a senior fellow at the Lockheed Martin Skunk Works. He was an engineer there. He was in leadership. He designed, developed, built the compact fusion reactor. Well, he's going to give credit to somebody else, but he's the one that made it possible. And his background and experience basically perfectly matches for somebody who made the orbs that we see in the MH370 videos. To the degree where it's kind of awkward because I can't even imagine anybody else being the person that made them. Honestly, it pretty much has to be him. But I also respect him. And anything that you see on one of his conferences that he put together, it's because he has inside information about what he knows is possible already. He already knows what we can do. He already knows we can teleport airplanes with magical orbs. So we all want to pay extra attention to the videos and the people that he is presenting, because you should be asking yourself, why does Charles Chase of Lockheed Martin want this person to present at his conference? Other presenters were George Hathaway. He's connected to Hal Puthoff. He's been experimenting, trying to prove zero-point energy, all this stuff. He hung out with John Hutchinson. He also had Sonny White and Garrett Modell on the show, or on the conference. Garrett Modell does not know. He does not know, guys. I pinged him, and his response to me, and I can kind of tell he has a certain innocence about him. He has a certain innocence. To be in the know on this, you kind of have to you have to have a way of compartmentalizing this information, because you're gatekeeping free energy from the world. And I think there's a certain aspect of physicists who like they think there might be something there, but they're not going to be convinced until, you know, someone wheels out the spaceship or whatever you would say. Then there's another branch of people that they know it's all real and they have to like tone it back a little bit. That is what Charles Chase can do. That's what Hal Puthoff can do. That's what Eric Davis is not quite as good at. The best ones can do it and lie and kind of weave a tale and kind of tell you what they want you to know the best. So here we have Yorichiro Tsurumaki. Oh my God, my Japanese is bad. And he is presenting conversion between radiative heat and dispersion forces and torques in non-reciprocal systems. Now you would look at that, and most people are going to look at that and they're going to go, what the hell does that mean? That doesn't mean shit to me. And what you don't realize is this is the most important presentation that we've ever had on this live stream. You go, Ashton, what? How are you serious? 100% serious. 100% serious. That's how easy it is to just hide something that is super, super significant. And again, I just want you to think about, why is Charles Chase, senior fellow at Lockheed Martin, inviting this Japanese guy to explain, you know, this conversion of heat temperature here? Okay, just think about it.
Theory and how that works, and contrast that maybe to what Larry Ford is going to talk about after lunch. So thank you very much, Yoichiro, for joining us, and please go ahead.
Thank you very much. I hope you can see my screen and can hear my voice.
Yes, yes.
Okay, thank you. Yeah. So my name is Yoichiro. Today, I'd like to talk about the conversion between radiative heat and the dispersion forces and torques in non-reciprocal systems. Okay. So it is well known nowadays that the radiative heat transfer between two objects significantly exceeds the black body limit when the separation between the objects is closer than around 10 micrometers around room temperature. This distance regime is called near field, and the enhancement of heat transfer is due to contributions from evanescent waves.
Okay, so right off the bat, he's saying that when the distances between the objects get super small, we have this overcoming of the temperature. There's some addition to the temperature that happens. And he says evanescent waves add to the heat transfer in the near field. They call it the near field. Okay, so now we have this concept of the near field, but what he's really saying is they're trying to understand what is the contribution of vacuum energy. What is the contribution of the Casimir effect, the negative energy, to thermal transfer, to temperature change? So imagine your refrigerator, imagine an air conditioner. That thing's blowing cold air at you, right? We're taught in thermodynamics that hot always goes to cold. That's what we're taught. What we're challenging here is that notion, but it's going to happen in a crazy way.
This is experimentally confirmed as shown in the left figure, where they measured the radiative heat transfer between silica, and the heat transfer exceeds over the black body as the separation between them gets smaller. Similarly, when the two charged neutral bodies are in the near field, the force acts between them. So this force is generally known as dispersion force or Casimir force. The Casimir force is typically attractive force, as shown in this light figure, and acts in the direction of the separation. So these effects occur in the near field, and our talk will be mainly focusing on the radiative heat transfer and momentum transfer in such distance regime. So the heat transfer and the force between the objects are caused by electromagnetic waves due to fluctuations of charges inside the object. This fluctuation is due to both quantum as well as thermal fluctuations. One framework that describes the radiative heat and the momentum transfer due to fluctuating currents is known as the fluctuational electrodynamics, which was originally proposed by Rytov back in 1959. In this fluctuational electrodynamics, we add a fluctuation current term in the Ampere's law, which is one of the macroscopic Maxwell's equations, and we consider it as a source of fluctuations inside the material. In order to know the transport quantities, such as heat transfer and the force, we need to know the correlation functions of these fluctuating currents, where this S means the symmetrized correlation functions.
Okay, I guarantee you it's going to get somewhere here, guys. Hang tight. If you're wondering what the hell is going on, what I want to point out as well is that evanescent waves, as JK Philly fan just pointed out, They were not just mentioned by Larry Reed, who is also a Lockheed Martin engineer. They were also mentioned by, what's his name? Gunther. Oh boy. The faster than light communication guy. Help me out, chat. I can't remember. Gunter Nimitz. Gunter Nimitz. Got it, chat. Got it. Never didn't have it. Gunter Nimitz was going to show that there was faster than light communication possible between two prisms. And he said that they were evanescent waves. Evanescent waves was connecting the prisms faster than the speed of light. Gunter Nimitz. Check it out, chat. Gunter Nimitz. Okay.
To know this correlation function, we use the fluctuation dissipation theorem. The basic idea is that the current response to internal fluctuations, so this correlation function, is the same as the current response to external perturbation, which is related to the dielectric function of the material, epsilon, as well as the temperature of the material. So by combining this fluctuation dissipation theorem and these Maxwell's equations, one can determine the radiative heat transfer and also momentum transfer in the near field. So our aim is to construct a heat engine by using.
Okay, so basically, what are they trying to do? They're trying to make a heat engine. Now, I don't know why these two things are connected, but they apparently are here. And he's going to explain why. But all of a sudden, we're going to get back to the heat engine thing at the end. All of a sudden, he begins to describe the movement and energy transfer of orbs. You heard me correctly. Here you go.
To the existence of lateral force between parallel plates, it was shown that the thermal radiation from a sphere that breaks the time reversal symmetry carries net angular momentum to the radiation when the sphere is in thermal non-equilibrium from the environment. And as a result, the sphere rotates. So this is the conversion of radiative heat into mechanical motion of the sphere. And the performance as a heat engine has been recently analyzed in this paper. Also, the transfer of angular momentum between two such spheres has been analyzed in this paper.
The angular momentum transfer between two such spheres has been analyzed. Okay. Are you going to show us that analysis? Yes.
Systems that consist of more than two objects, which we generally call many-body systems, it is known that the radiative heat transfer between multiple objects that break time reversal symmetry exhibits non-trivial peaks. However, fluctuation-induced force and torque transfer in such many-body systems that break time reversal symmetry has not been studied. So given that interesting physics predicted in heat transfer in such systems, we are interested to study temporal dynamics of many-body systems through the force and the torque transfer.
So they're studying the temporal dynamics of many-body systems. Checking the temporal dynamics of many-body systems to check for, you can break time-reversed symmetry. This basically is trying to figure out how to teleport, I think.
So we studied force and torque transfer in many-body systems when the objects are at rest, and this can be considered as a first way to understand the temporal dynamics. In today's talk, I'd like to first...
Hold up. Pause, chat. Pause. What the hell am I looking at right here? What am I looking at right here? The hell am I looking at, chat? Casimir force and torque between many non-reciprocal systems. And I'm just looking at three orbs look like to be spinning in an alignment linked up with one another. And you can see their internal spin as well right there. Are you kidding me right now? Global rotation and rotation around own axis in thermal non-equilibrium. Okay, please go on.
Discuss the fluctuation-induced force and torque transfer between spheres under the static magnetic field. And we show that a variety of motions, such as a global rotation around the center of mass, the self-propulsion, as well as a spinning around its own axis, can occur in thermal non-equilibrium.
Okay, chat. What? I mean, what? You can see the B field here as well, which is perpendicular, of course, to the axis of rotation of the orbs, which we already know that. Because you can imagine the plane at the center of those orbs, it's going to go that way, backwards. It's going to go backwards. Like literally, those orbs are spinning counterclockwise, the same direction as the plane. When you ask me, where is the plane going to go? It's going to go that way. It's going to go that way, chat. And with respect to the plane, that's backwards. That's west. That's west. That's going to the Maldives. There it is right there. Why does Charles Chase, this is 2022. This is before I ever saw the videos. This presentation was before I ever saw the videos. Why is Yorichiro, oh man, Yorichiro, why is he presenting this to why was a Lockheed Martin senior fellow interested in this presentation? I have a few thoughts.
In the last part of my talk, we also discussed our recent effort to propose a heat pump that converts the kinetic. So here I show why thermal radiation from a sphere carries angular momentum when the time reversal symmetry is broken. So the left figure shows the spectrum of thermal radiation from a indium antimonide sphere under different magnetic field as a function of the wavelengths. So when the magnetic field is 0, which corresponds to this blue line, the 3 dipole modes of localized plasma resonance are degenerate, and we only see a single peak around these wavelengths. When we apply a magnetic field to this sphere, these dipole modes become non-degenerate, and the single peak splits into 3 peaks, these 3 peaks, where the 2 peaks on both sides correspond to the dipole modes that carries opposite angular momentum. So the right figure shows the pointing vector from these.
I don't know what to make of this slide. This seems really, really significant. It seems like they have set up some type of quantum like entanglement. This seems like entanglement, right? Like they're like, when we apply this magnetic field, we get 2 counter-propagating waves, right? They're saying normally there's no magnetic field. We're in the middle. We're just in this one coherent wave. We apply this magnetic field. We have 1 positive, 1 negative. I think that's what he's saying right here. Everything boils down to dipoles.
These 2 dipole modes that shows the Swaring thermal radiation distribution, but in the opposite direction. So they carries opposite angular momentum. And these 2 modes that are situated at different wavelengths are populated thermally populated differently. Therefore, the thermal radiation from this sphere carries a angular momentum.
So when we're watching the orbs, remember they were all green. They were all green. I imagine all green is equivalent to 0. M equals 0. And then what do? They add a temperature difference. All they have to do is add any asymmetry to the orbs, a temperature difference, and what's going to happen? They're going to begin to spin. They're going to begin to spin just because of a non-equal, because there's going to be some asymmetry. That's what this presentation is about to say.
So this is the pointing vector distribution of a thermal radiation emitted from a magnetic wire metal, which is the material we are going to discuss throughout our talk. Although I do not introduce this material in detail, whenever I show the AR in thermal equilibrium. And so this can be seen from these figures where I show the pointing vector distribution. And
what he also says here, I'm going to skip through part of this, but we're going to get to the good stuff, is that calculating this stuff in 3D is really difficult. Part of the reason why we haven't been able to get this all figured out is like, how do you calculate how to make a bubble in 3-dimensional space using 3 plasma orbs? That's really complicated. It's really complicated math. And that's what essentially they're saying, well, okay, well, we can figure out ways to simplify this. We can get to the core theory of it, and it'll make it easier.
Around the sphere.
Okay. Let's see. And then he's just showing that you can actually prove that there's going to be a force. With the magnetic field off, you can prove there's not going to be a force. With the magnetic field on, you can prove that there's going to be some rotational force on the orb just by having a magnetic field applied. That's it.
Intuitive arguments. So the formalism that we have developed is based on the fractional electrodynamics formalism. And the way we compute the force as well as the torque is by determining the Maxwell's stress tensor and also the angular momentum flux. And we integrate over the surface of the sphere of interest. And in order to compute those Maxwell's stress tensor and angular momentum flux, we need to determine the total electromagnetic field around the sphere that includes all the possible scattering events that can happen in the system that in general contains multiple spheres. And so to determine that, we use the scattering formalisms based on the previous work that has developed this formalism extensively.
So scattering. Scattering is something I'm going to have to look up more. So it has to do with light. It has to do with how light bounces off objects. But I think that you see scattering a lot in the context of teleportation and wormholes, because essentially we're using electromagnetism to change the direction of light, change the speed of light. So scattering becomes extremely significant.
So our formalism is exact in the framework of the fractional electrodynamics, and it's analytical, so it can be computed relatively fast. Okay. And it's also applicable to arbitrary number of spheres and arbitrary dielectric functions of the sphere. So as an example of thermal non-equilibrium situations, we consider two spheres under the same magnetization direction and at the same temperature at 300 Kelvin, but there's a thermal non-equilibrium from the environment. So it is well known that the radiative heat transfer I'm sorry, on the left figure shows the radiative heat transfer between the two spheres, which is the blue line, as well as the from the sphere to the environment, which is this red line. Because the distance is relatively far, most radiation goes to the environment, and therefore the total radiation and the radiation to the environment almost overlaps. And as you can see, we can see several peaks, and this peak here corresponds to the M equal 0 mode, where this peak always exists even if we turn off the magnetization.
So he's saying here, okay, we got some orbs flying through the sky, and of course they're going to lose some energy to the environment, but they're also going to be exchanging energy with each other as well. And that exchange of energy with each other is going to change how they spin, change how they move, change how they interact with one another.
And as we apply magnetization, these peaks will split into both the lower frequency as well as the higher frequency part, and we see similar peaks. On the right figure, we show the force acting on the sphere 2 in the y direction. And as I explained in the intuitive argument, if we consider the case where if we don't apply the magnetic field, there shouldn't be any lateral force. However, if we apply the magnetization, then the lateral force exists. So this figure on the right shows the different contributions on the lateral force acting on the sphere 2. And the contribution mostly comes from the radiation due to the its own emission. So the emission from the sphere 2 will experience the scattering and will act back on the sphere itself. And as you can see, these peaks corresponds to these peaks that we see in the radiation spectrum. And these peaks actually corresponds. So if the force acting on the sphere 2 is in the minus y direction, then the same amount of lateral force will act on the sphere 1, but in the opposite direction. And therefore, these two spheres will start to rotate around the center of mass of this system.
Wow. So he said, if you apply a force to one of the orbs, you will get an opposite force on the other orb, and it'll begin to rotate around the center of mass of your system. Bingo. Bingo. That is exactly what I was looking for. That was exactly what I wanted to find. That you can, all you have to control is the temperature. A lot of this all goes back to energy. They've figured out free energy in every possible aspect, guys. They figured out perfectly efficient systems. They've figured out how to convert ambient vacuum energy into electrical energy. They figured out how to convert heat into electricity as well, whatever they need to do at extremely high efficiencies that just blow anything we have completely out of the water. That's what this is all really about. But on the side, we also get a bonus where we get to figure out how the orbs are operating, because those orbs are just electromagnetic balls of energy. And he's explaining exactly how these orbs work.
And not only that, because the angular momentum transfer occurs in thermal non-equilibrium, these two spheres will also start to rotate around its own axis. And the direction of the spinning is the same, again, due to the inversion symmetry of this system. And here on the right figure, I show the torque as a function of the spectrum.
There you go. That right there is proof. I haven't even looked and they've been able to confirm yet but this means the orbs, their axis of spinning must be the same. Now, at least assuming it's in this configuration. And don't worry, he's going to show some configurations here at the end as well. So if there's a force that acts upon them, they're going to begin to spin around the center of mass, and their individual spins should line up. The individual spin of axis of the orbs itself should line up. There should be symmetry. There should be symmetry. So we can tell the videos are real because we can tell we're looking at real physics because each orb is interacting with each other orb. And they're going to be perfectly aligned. They're going to be perfectly aligned. We know because they're in a perfect triangle. And I know that because I know those videos are real already. So I know that that physics is going to check out. The hard part is looking at the videos, even in slow motion, there's not a lot of frames where you can see both orbs clearly to watch them spin in alignment. But it looks like in these frames, all three orbs, the heat signatures of the orbs are lined up. You can't really tell because this one goes off the screen for a second. It looks right there. That right there. You can see it, right? Look at the heat signatures of all three orbs. They're all perfectly lined up. Perfectly lined up. Wow. Look at that. Right there. Each orb is just angled slightly differently. Perfect symmetry, right? The top orb is angled to the left. This one's angled to the bottom. This one's angled to the right. Booyah. Why? Why? Well, you're listening to why. You're watching why right here. That's why. That's why right there. They have to be perfectly aligned. They must be.
On the sphere too. And as you can see, it's clearly non-zero and in the x directions. So here on the left figure, I show the force in the x direction.
Oh, no, this was actually super important.
Thermal contributions. But the force can also act due to the vacuum fluctuations, but it only acts in the x directions. So here on the left figure, I show the force in the x direction as a function of the distance in thermal non-equilibrium situations. And as you can see in the separation, when the separation is small, this vacuum fluctuation contribution, or the usual Casimir force, dominates over the contribution from the thermal radiation. And so,
holy shit. Did you guys hear what he just said? He just solved it right there. This presentation was the Holy Grail. I listened to it again earlier today, and I just couldn't even believe it. When the distance between the orbs is very low, the vacuum energy dominates. The Casimir effect dominates. When the distance is very high, the thermal energy dominates. What is the Casimir energy, chat? What is the Casimir energy? The Casimir energy is the negative energy. So when the separation between the orbs is very small, the Casimir, the negative energy, goes up. The negative energy is what we need for our wormhole. Why are the orbs converging? The orbs are converging because that is increasing the contributions from the vacuum energy according to this graph right here. This is what this graph experimentally shows. Right there. That is peer-reviewed scientific proof. Right there. D divided by R. Wow.
When the separation between
I'm going to play it again, just so you guys can hear the whole thing.
So here on the left figure, I show the force in the x direction as a function of the distance in thermal non-equilibrium situations. And as you can see in the separation, when the separation is small, this vacuum fluctuation contribution, or the usual Casimir force, dominates over the contribution from the thermal radiation. And so when the separation between the two spheres is close, the force is attractive. And when the separation between the four spheres is large, then the thermal contribution dominates over the vacuum contribution, and the force becomes repulsive. And on the right figure, I show the...
and there it is. And what he means, and so there's actually a point on this graph right here that shows the exact position where the orbs would be, where they're in perfect equilibrium. So basically the point is the point where the vacuum contribution matches the thermal contribution, the orbs will neither separate nor converge. They will lock in that exact position. They will find an equilibrium point. That's why the orbs are at a certain distance. And if they get closer, then the vacuum fluctuations overtake it. So in fact, if this is true, if this is real, then the moment that they change the orientation of the orbs, they sent a message to change the mode of the orbs. The moment they change, boom, they just instantly converge towards the plane and accelerated towards it. Accelerate towards the plane, poof, gone. Gone. Why? Because as the distance between the orbs converges, the energy, the force from the Casimir effect, the negative energy begins to overtake it.
The force, which is solely due to the thermal Casimir force as a function of the separations. And throughout the distance regime that we studied, this direction of the lateral force does not change.
Don't worry, there's more.
We can also think about changing the direction of the magnetization. In particular, the material we consider, the magnetic quasicent metal, is a ferromagnetic material. So this can be achieved by flipping the direction of the sphere. So if we think about the case where the magnetization...
So that wasn't enough. Now we can think about what do we do if we flip the magnetization of one of the spheres? And flipping the magnetization of our spheres is just literally flipping it over. Literally flipping it over will change the magnetism of the sphere. So what do we do if we change the magnetism? In fact, how does it work if multiple spheres are linked up and they each have their own magnetism? Remember, I told you guys, go back and watch my live. This is crazy to watch this because I deduced this. I said that each orb is basically a 1 or a 0. It's either an on or an off from an electromagnetic perspective. And then they've got them linked up, and then they can change the modes by just flipping. Okay, this one's on, and off, or all three on, right? That's how they're manipulating the orbs. Just a 1 or a 0.
Direction is the anti-parallel. Then this system now has the mirror symmetry because across this center plane, if we operate the mirror reflection, the direction of the magnetization is flipped. And therefore, in this case, if the lateral force exists in one direction, then the lateral force on the other sphere has to also act in the same direction. So in this case, these two spheres does not experience a global rotation, but it will experience a self-propulsion in the same direction. And the direction of the self-propulsion propulsion can change as a function of the distance due to the changing interactions.
So what we're hearing right here is how do they control them? How do they change them from spinning in a sphere around the plane to going perfectly vertical? He's saying right here, we just flip the magnetic fields relative to one another. If you change the magnetic fields relative to one another, you can control their axis. You can make them just begin to spin only this direction as opposed to just spinning in all directions.
So the electromagnetic.
Again, this is just a 2-body system that he's showing right here because in a 3-body system, you have additional degrees of freedom. It becomes difficult.
Moves between the spheres as a function of the distance. So this motion is actually related to the torque transfer between the two spheres. So if we look at the torque transfer between the two spheres, then because of the symmetry, the torque acting on the sphere 2 is the opposite to the torque acting on the sphere 1. So in this case, whether the system is in thermal equilibrium or non-equilibrium, the total torque exchanged between the two spheres and the environment has to be 0. There shouldn't be any net transfer of angular momentum. This we rigorously calculated the transfer of torque acting on the two spheres. And as you can see, the torque acting on the sphere 1 exactly cancels with the torque acting on the sphere 2.
So again, all of this goes back to conservation. It really goes all back to conservation. Everything has to cancel out. Everything has to cancel out. And so at the end of the day, people say, well, how is free energy real? Because at the end of the day, if I just need 2 things to cancel out, I'm allowed to have 2 things over here and 2 things over here. In fact, I'm not limited to that. I can have 10 things over here and 10 things over here, or 1 million over here and 1 million over here. This is what opens the door to free energy. Because do I have 0 things? No. And this is the same thing about scalar physics. I don't have my rubber band handy. I wish I did. But if I pull on my headphones, just because I pull equally on both sides doesn't mean there's nothing here, right? I pull equally on both sides really hard and my headphones are going to rip in half. This is the same concept. Is how is free energy real? Well, free energy is real because we can break symmetry. We can break symmetry. That's the idea of people say making something asymmetric. Yeah, you want to rip, like pull on, like pulling on a guitar string. Pull on a guitar string is going to vibrate. You can take advantage of that.
Because there is no torque transfer to the environment, the motion of the two spheres shouldn't also have any angular momentum. Right, so the self-propulsion does not have any angular momentum. So these two results make sense. So I mentioned that the lateral Casimir force is solely due to thermal contributions. However, the lateral force can also act even in global thermal equilibrium. So one question that we asked is that we can consider different orientations of the magnetizations in the spheres, but which configuration is most stable? So we studied the Casimir energy for different orientations of the magnetization for both parallel and anti-parallel case at the global equilibrium at 0 Kelvin. And we found that the most stable configuration is when the magnetization is parallel and the direction is perpendicular to the separation directions.
The most powerful negative energy is when the magnetism is parallel. I got to hear that again. What do you say?
At 0 Kelvin. And we found that the most stable configuration is when the magnetization is parallel and the direction is perpendicular to the separation directions. So what it means is that if we think about two spheres, such as this, even global thermal equilibrium.
There it was. It's when the magnetic fields are parallel and the force is perpendicular. Perpendicular. What is he saying right there? Where's the plane going, Shat? It's going perpendicular. Why are they spinning around the plane vertically? Perfectly vertically. They're spinning around the plane perfectly vertically because they're sending that plane backwards. If they were spinning around me, I'm going back. Right? That's what he's saying right here. The equilibrium position. Look at that point where the Casimir effect and the negative energy gets stronger. So this is why the spin of the orbs, the position, the orientation of the orbs is super important. It's exactly how they're pulling this off. There's an additional slide coming up as well.
The lateral Casimir force will act in this direction so that this particle will be pushed back towards these positions, which has the lowest Casimir energy. So as a representative case of a many-body system, we consider three spheres on the vertices of the equilateral triangle. And there's a very interesting work from Professor Xianghui Huang's group that if we think about three systems under magnetic field, the thermal radiation between each sphere and the environment is equal, meaning that there's no net heat flux between the environment and the spheres. But when we look at the radiative heat transfer between the spheres, the amount of heat from the sphere 1 to 2 is not necessarily equal to the heat from 2 to 1. And
I just have to say again, guys, why is Charles Chase, senior Lockheed Martin fellow, have this presentation as one of his presentations alongside Sonny White, Garrett Modell, all about free energy? A three-body system exchanging energy with one another. Three-body system. Now, where's the last part I want to show?
Transfer between the sphere 1
I think he says something else right here.
Than the temperature of the sphere 3. And so this is an interesting system. And we also looked at the force transfer and the torque transfer in this system. And so here I showed the torque acting on the sphere 2 due to the thermal radiation from the sphere 1, and also the torque acting on the sphere 1 due to the sphere 2. So we are looking at the torque transfer between the sphere 1 and the 2. And as you can see at the frequencies where the heat flux becomes different, the angular momentum or the torque transfer also becomes different. So this indicates that the existence of...
By the way, this is definitely the math that they used to figure out how to get their three orbs to spin around an object and make it disappear, and probably do other stuff as well. I mean, I don't think they're limited to just teleporting some plane. They can probably do crazy amounts of stuff, but this is the science, basically. I mean, why is some guy reviewing three orbs and like how they interact with from temperature perspective with one another? Because they can just use temperature to control the orbs.
The persistent heat flow also indicates the existence of the persistent angular momentum between the three spheres. So similarly to their proposal, if we think about the thermal non-equilibrium situations where the sphere 1, for instance, is at a higher temperature than the sphere 2 and 3, because of this imbalance of the angular momentum flux, the sphere 2 will start to rotate faster than the sphere 3. And that may actually be used to indicate the existence of the persistent flow of heat as well as the angular momentum.
So they can use the temperature to basically turn the orbs on. So like you would say, how do you turn the mode of the orbs on? Like literally you might just, all you have to do is change the temperature of one of the orbs like 1 degree. You might be able to do something like that to basically just have the orbs all of a sudden start to move and start to spin. But I definitely think there's some kind of AI system. Like I think you just feed the AI all these equations and you tell it the math and you just have the AI just like, you know, keep everything perfect.
So similar to two-sphere case, we also looked at the thermal no-equilibrium situations where the temperature of the spheres are 300 Kelvin, but the environment is at 0 Kelvin. So we know that in this case, there's the net angular momentum transfer to the environment. And as a result, there's the lateral force acting in the x directions, as well as the net torque acting on each sphere. And so these three spheres will start to rotate globally, as well as they spin around its own axis as we.
Holy shit. I mean, that's it right there. Clip that. Clip this part of the video. There it is. What's going to happen? Let's go back a little bit.
Net angular momentum transfer to the environment. And as a result, there's the.
Oh, hold on. We got to go back a little bit more.
The persistent flow of heat, as well as the angular momentum. So similar to two-sphere case, we also looked at the thermal no-equilibrium situations where the temperature of the spheres are 300 Kelvin, but the environment is at 0 Kelvin. So we know that in this case, there's the net angular momentum transfer to the environment. And as a result, there's the lateral force acting in the x directions, as well as the net torque acting on each sphere. And so these three spheres will start to rotate globally, as well as they spin around its own axis.
So even when all three orbs are at the exact same temperature, there's some angular momentum being lost to the environment, and this is what starts the orbs to spin around. So what I'm gleaning here is that when the orbs are spinning around the plane randomly or like in a sphere, that's just random. That's just like that they just have to do that once they're locked in. And then they're probably being turned on the moment they begin to like reorient and go vertical. That's probably someone, click the go button. And then once they achieve maximum whatever the hell, they converge on the plane and boom, gone. And they're spinning around the plane probably to make those invisible tendrils, that spiral that connects it to wherever they're going.
We discussed in the two-sphere.
No, it's very technical and
finally, we also looked at the stability of the different configurations
now
of
we're talking
magnetization directions in the three spheres, and computed the Casimir energy to determine the most stable configuration.
Okay. This is the sauce. This is all the configurations, guys. Go look at my past live stream. I don't even remember which one it was, where I said you can imagine each one is an up or a down. These are the various configurations. And that graph on the right is which configuration has the strongest negative energy. Which configuration has the strongest negative energy? It's D. D right there. D does.
So these three red lines correspond to the three top cases where the magnetizations are in the plane of the triangle. And in this case, the Casimir energy varies little, which means that the different configurations can be taken if we apply a small perturbation. What we found is that similar to the two-body case, the most stable configuration is here, which means that when the magnetization direction is all parallel and perpendicular to the plane of the triangle.
Perpendicular to the plane of the triangle. The most powerful Casimir effect, the most negative energy, is when it is perpendicular to the plane of the triangle. That's exactly what we're looking at. We have this triangle, right? Like this, right? It needs to go this way, perpendicular. Perpendicular is like this. In fact, where's my plane? So the plane is spinning, and our magnetic wormhole theory and our Yoichiro theory of our orbs here is that this plane is spinning, right? It's hitting this wall. The orbs are spinning around it. It's going to get pulled backwards. Okay, it's spinning. Plane is going. Wait, yeah. And it's getting pulled backwards faster than the speed of light through an extra dimension, as we would think of it. Through an extra dimension, and then it's reappearing somewhere else. Almost like there was something stitched, right? And it just disappears and then reappears on the other side.
So we studied force and torque transfer among the 2 and the 3 spheres at the rest. And so our current work is to study the temporal dynamics in this system.
Okay. So they want to test the temporal dynamics of the system. Now, that's basically the end of that particular part of the presentation. Now, that part, I say, guys, Charles Chase did not reply to my email where I basically just asked him if he made the orbs. But he did reply to my LinkedIn friend request where I said that I love his coherent matter wave beam pattern. And there's really only one reason why he wouldn't respond. I mean, this is his conference we're watching right now. This is Charles Chase's conference we're watching right now, where he's explaining how some magical orbs can spin around and create different magnetic fields and the temporal properties of some orbs and their various magnetic fields. Okay, if you're still not on board with this, I'm just not the right follow for you guys. If this is not convincing enough for you, if this content is not convincing enough for you guys, yeah, maybe, I don't know, find Hello Kitty Island Adventure. Maybe that's more your speed. The next part of this, he basically explains how we can break the laws of thermodynamics, how we can create a situation, a system by which cold will flow to hot. Hot normally flows to cold. How we can get cold to flow to hot. Experimentally. Can do it. Here you go. And so we're going to watch the next 10 minutes or so of this because honestly, he deserves it. Like, look at what we just saw here with this. And now this same guy is going to be like, hey, by the way, not only did I just show you how some magical orbs can break time reversal symmetry, but in addition to that, I'm going to show you how we can get cold to flow to hot. How we can basically break entropy. Break entropy. Okay, I'm in.
While these are fundamentally interesting, it will not be practically useful as a heat engine. Practical heat engines needs to be extensive, and therefore, planar device configuration is desirable.
So this is basically a heat engine or a heat pump, if you want to think of it like that. Why? Because you're pumping something from the cold area. You're pumping heat from the cold area to the hot area, which everybody would say that's impossible. Well, again, why does Charles Chase have this guy on? Because Charles Chase knows this is not just possible. He knows it's real. And he's looking for the physicists and the scientists, the experimentalists who are proving it. And he knows which ones are real.
For this purpose, we consider 2 parallel plates where the external work is applied to one of the objects, particularly in this case, a colder object. And we discuss that the radiative heat transfer between the 2 slabs flows from a cold object to a hot object, thereby achieving a heat pump. So the physical mechanism of achieving a heat pumping is as follows. So if we consider a situation where a body 2, which is at a lower temperature, is moving at a velocity with respect to the body V. We consider the heat flux from body 2 to body 1 at the frequency omega prime measured from the observer that moves with this body 2. Let's say this is a omega prime.
Okay, I'm going to keep it simple for you guys. What is he talking about? How do you pull this off? You just get one of the people to move. If one of your objects is moving really fast, then it's going to change the wavelength or whatever, and therefore makes it cold, right? Okay, there you go. That's basically the answer. That's omega, wavelength, frequency, whatever. Okay, so if you have one of your objects moving, you can use the same general relativity. The same general relativity. We live in a bubble, right? So from our perspective, it's going to look like this object is cold because either we're moving super fast or the object's moving super fast. That's basically the premise here.
This way, you can see that the emission is exponentially enhanced by this factor, which is proportional to the qx, which is the wave number in this direction of the motion, times the velocity. So the heat flux from body 2 to body 1 is exponentially amplified. Now, if you look at the opposite direction, then the heat flux is exponentially suppressed because from...
So basically, you can either look at it from the perspective of this heat flux is going to be amplified or it's going to be suppressed. So essentially, through movement, we can suppress or amplify heat. We can create a heat engine, a heat pump.
This observer's point of view, now the wave is going away by the velocity of this body 2, and therefore the Lorentz transformation of the frequency of the light direction, then we can exponentially amplify the heat flux from the body 2 to body 1. And when this is sufficient, even when the temperature of body 2 is lower than the temperature of body 1, we can create a net heat flow from body 2 to body 1.
So assuming we have the right velocity, we can cause a net heat flow from cold to hot.
So we developed the fluctuation dissipation framework to calculate this. And we first considered a case where the two bodies are in germ antimonide. And we create the temperature difference of the 1 degree. And the separation is 10 nanometer. So this is in the near field. And we apply the magnetic field. And we move this body 2 at the velocity 10 to the 4 meter per second. On the right figure, I show the heat flux from the body 1 to 2 as a function of the velocity. So when the velocity is small, the heat flux, which is this blue line, which corresponds to the left axis, is negative. This is understandable because heat flow should be from a higher temperature to a lower temperature. However, as you increase the velocity, then the direction of the heat flow starts to decrease. And then when the velocity is sufficiently high, the direction actually flips. So from this calculation, we found that the velocity that is required is on the order of 10 to the 3 or 10 to the 4.
So what he's saying here is that in order to make this happen, if you look at the chart on the right, at the bottom on the x-axis, it says we need a velocity of 10 to the 3, not that high, 1,000, or 10,000 meters per second in order to achieve cooling effect. And if we do that, we can break the laws of entropy. We can have cooling occur. You can have heat transfer from cool to hot.
So the question is, how do we achieve such a high velocity?
How do we do it?
So interestingly, experiments suggest that instead of moving the material, if we apply a bias in the material, and electrons will flow inside the material through the static ionic background. These moving electrons can assimilate the moving body.
So we create a simulation of it. We create an electronic bias, an electric bias. So presumably we add an electric charge. I think that's what he's saying here. We add a bias, and then we can cause the electrons to move. So instead, we're going to cause the electrons to move. And what are we going to use? What material do we think is going to be really good for having our electrons move around?
And so if we apply this, then instead of moving the entire body, we can apply an electric bias to the material and then let the electrons flow. And this flowing electron will function the same as the moving body. And for this purpose, we found that the graphene is particularly interesting because the drifting velocity of massless Dirac fermions can be as high as 0.1 of the Fermi velocity, which is the 10 to the 5 meter per second.
Graphene, chat, graphene. Everybody's been talking about graphene, and now all of a sudden we know why graphene is so important for free energy. Right here, he's saying graphene has high group velocity of massless Dirac fermions. It can achieve 10 to the 5 meters per second. And he's saying all we need is 10 to the 3. We don't even need that many zeros. So graphene, if we apply an electric field to graphene, is it going to just start cooling down? Is it going to just start cooling down when it should heat up? Is it going to be able to radiate heat from cold to hot? That's what this is saying.
Also, graphene has a weak phonon-mediated radiative heat transfer, which usually is gives an adverse effect to achieve cooling. So as a prototypical system, we considered 2 suspended graphene sheets at the 2 different temperatures, where the one graphene sheet is at 300 Kelvin. The other graphene sheet is 5 degrees higher than this graphene sheet. The separation is 10 nanometer. And we considered a reasonable drift velocity of Dirac fermions inside the graphene sheet, which is the 0.3 times the Fermi velocity. And what we found is that in this case, the net heat flow flows from a lower temperature to a higher temperature, thereby achieving a heat pump.
Wow. I mean, why do I love this so much? It's so simple. It's so damn simple. Just he's basically saying 2 sheets of graphene. We're going to apply electric current or magnetic field to one of them. So these electrons are going to flow really fast. And because graphene has this property where the electrons flow really fast, that's going to create our difference that we need. And because they're going to have a difference of the flow of electrons on this plate and this plate, you're going to have heat go from the colder one to the hotter one. Heat is going to go from the colder plate of graphene to the hotter plate of graphene. Breaking the laws of thermodynamics. Easy. easily breaking the laws of thermodynamics. In fact, screw the laws of thermodynamics. Those don't mean shit to me. I don't live by your laws, by your made up imaginary laws. Reality doesn't care about your fake laws. It does kind of remind me of Dr. Deborah Chung as well with her negative resistor. Very similar, I think. So we definitely are going to be looking into graphene on Friday, guys. And this is going to be super important. So this isn't just kind of to wrap this stream up, but this is going to feed into the next stream where we found another free energy device. This is also free energy too.
And here I show the heat flux.
And in the bottom right, you can see the coefficient of performance. See the bottom right? Coefficient of performance. What does that say? Oh, that says greater than 1. Coefficient of performance is greater than 1 because they can calculate what is the net input current. That's the bottom left chart. Net input current to achieve the velocity is the bottom left chart. Bottom right chart is the coefficient of performance. That is like 3. COP of like 3, I think, right there. Coefficient of performance greater than 1 is called over unity. I like to call it free energy because what it literally means is that you are getting more energy out of your system than you're putting into your system locally. That's what that means right there. You're seeing the chart. You see it with your eyes. This is a peer-reviewed scientific paper. You're hearing from a world-renowned scientist.
From the body 1, sorry, the lower graphene to the higher graphene as a function of the velocity. And as you can see, as the velocity increases, the heat flow direction flips, which means the cooling. The required work to flow these electrons or the Dirac fermions inside the graphene can be estimated by calculating the drag force acting on this.
So Chupa is ahead of the game here, but basically Friday is what we're going to be looking at. Friday, we're going to be showing that you can make an infinite battery out of this. Using this concept, you can make an infinite battery that its equilibrium is for it to be charged. Its zero is energy. And it will always go back to trying to achieve X amounts of energy, electricity within it. And if you say to me, Ashton, that's not possible, I say, you need to learn about Tesla. You need to learn about Tesla. Ashton Forbes is teaching you and telling you that free energy is 100% real. And I'm not just teaching you, I'm also showing you the scientists who've already figured it out.
Electrons, which is given by, which is shown in this figure, times the velocity. On the lower right figure, I show the coefficient of performance of this system. And as you can see, when the velocity exceeds, for instance, 0.4 of the Fermi velocity, the coefficient of performance can exceed 1, which means that we can achieve net cooling. So we studied the thermodynamic efficiency of this system as a heat engine. So in this case, we consider the body 1 is at a higher temperature than the body 2. So the heat flow is body 1 to 2. And we assume that there's a force acting on the body 2 that is moving at the velocity v. And in this case, by using the fluctuation, this electrodynamics framework that we developed, if we define a thermodynamic efficiency by the ratio of the work on the body 2 divided by the heat flux, then we can prove that this efficiency bounded by this expression here, which is the Carnot efficiency, but we have this gamma term, which is the Lorentz transformation factor here. So this can be understood that this efficiency, all the quantities are defined in terms.
So basically, he shows some equations here, and then they get to some questions here as well. And Charles asks about, like, there's some controversy over whether or not things cool down when they approach the speed of light. And basically, he long-winded gives the answer that essentially all they did was just throw the Lorentz transformations in there, and then out came the gamma, which is in the negative or in the denominator, which shows this cooling effect seems to happen. But it doesn't necessarily mean, like, I don't know. He basically gives some answers, says it doesn't really end the controversy. So all these guys are fence sitters, basically. None of them want to be like bold about their predictions. They say, well, this is what I think the scientific theory shows, blah, 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 blah. But end of the day, he's definitely showing heat going from the colder region to the hotter region. No question. And he taught us about how all the orbs work and how they spin around and how we know now for no question, no doubt, when we see the orbs or more footage of those orbs, we're going to know that they're going to all be in alignment. We're going to know that they're all going to be in alignment because of their combined magnetic fields and how they're interacting with one another.
It's the same. So there's whether the gamma is in the whether it's in the numerator or denominator or not needed at all is in question. So why did you choose the Planck-Einstein approach?
I think he gets asked another question here. I want to
cannot be used. So when we consider these two effects,
so therefore, your result does not do anything to resolve that controversy about the temperature of a moving body, and it's based on your definition of the thermodynamic efficiency.
Right. So we do not transform temperature. We do not do the Lorentz transform of temperature. What we do is the Lorentz transformation of the electromagnetic waves.
Next is lunch, and after lunch, Professor, very exciting result.
Okay, so actually, the thing was in the beginning. He asked it. Here we go.
Efficiency of the heat pump is, and I'd like to finish my talk. I think I'm a little bit over. I apologize for that.
Lateral Casimir force and torque in thermal non-equilibrium lead to a variety of dynamics in sphere motions. Like when I'm looking for scientific explanation for what the orbs are doing in teleportation, like this is about as close as I've ever gotten. This is about as close in combination with the magnetic wormhole paper that I showed you guys earlier. But like, there's not a lot of papers out there like, okay, here's 3 orbs spinning around and how they relate to 0 point energy. Not a lot of papers like that. It's oddly specific. Oddly specific.
Yeah, thank you very much, Yoichiro. Very interesting new results on the dynamics between multiple particles and the non-equilibrium fluctuation forces. And then
yeah, really interesting results on those multiple particles and the non-equilibrium fluctuation contributions. Yeah, the way he says that is like he's just ordering McDonald's. Like, what do you mean kind of exciting? Like, you know that we can teleport stuff with magical plasma orbs. That's the reason why you had this guy on, right? Like, let's just be real about it.
Also on the cooling that you can achieve between moving objects. And it'd be interesting to know, really, does the electrons moving without the lattice moving, is it really something moving, or is it just an effective motion? And I guess that that paper that was published in Nature is they feel pretty strongly that is the case. Is that correct?
Yes, I think so. Yeah.
So that was a weird comment that he made as well. He's saying, if you can do this with just the electrons moving, but the lattice is not moving, the physical structure is not moving, what does that mean? What does that mean? I think what he's implying is we're in a medium, that you must be interacting with the medium when you're doing that. Because otherwise, how are we accelerating this electron infinitely that direction? I don't know. Maybe I'm wrong, but that's my impression. The impression I get from that is he's saying maybe it's just an apparent motion that's really happening. And we just need this apparent motion to happen because we're manipulating the medium, and that's what causes this effect to occur. I think that's what he's alluding to right there. So the last thing I want to go over tonight is just a simple query that I fed into AI. I like the most simple queries. I don't like to sit there and have a big, long conversation with the AI. I just want to feed it something basic, and I want to get out a response. So I told the AI this. Use the concept of a magnetic wormhole to explain how 3 spheres of plasma could be used to combine and enshroud an object to teleport it to another location. The reason why I used that is my input was obviously the magnetic wormhole thing, but also this clip.
Positive things that can be used for.
You name something you want that's good.
So Ken Shoulders right here. This is really Ken Shoulders. That's John Hutchinson standing next to him, by the way. That's the same John Hutchinson that George Hathaway in one of these calls from that conference was talking about. Praising him.
Does make atoms disappear.
So this is what EVO's plasma balls can do.
When it enshrouds things, it can allow them to disappear. It does make atoms disappear in laboratory work.
What did he just say? When it enshrouds things, it makes them disappear. It does make atoms disappear in laboratory work.
Well, that's interesting, because when they disappear, I can transport all this stuff through somewhere else, and it reappears. That's teleportation. So it does.
That's teleportation.
That very nicely.
It does that very nicely. He's just straight up saying it right there. So what does the AI say? It says if we assume we have three distinct plasma spheres, it didn't quite understand what I was trying to say. It kind of thought that we had plasma spheres at each like location, but it was still pretty close. It says, under precise control, the three plasma spheres are brought together and merged. The entry and exit spheres align their magnetic fields to form a dipole-like configuration, while the throat sphere extends and connects them. So what is happening? That is what's actually happening. We're creating a dipole. The plane disappears at one location, point A, the negative side or positive side, doesn't matter, just a dipole, and it reappears at the opposite. They create a dipole connecting 2 points in space and time just like this. One's a positive, one's a minus. They're not restricted by time, not space and time. These spheres, whoops. As they combine, the plasmas intermix, creating a unified, layered plasmoid structure around the object. I can't believe it says all this. The outer layer acts as the ferromagnetic shell, concentrating and guiding the intense magnetic fields towards the object. The middle layer behaves diamagnetically, expelling erroneous fields to cloak the transfer process. The inner layer forms guiding hose of force-free plasma currents where magnetic pressure sustains a stable tunnel. When the objects combine, the merged plasma structure fully enshrouds the object, embedding it within a cocoon of swirling plasma. This enshroudment generates enormous magnetic fields that interact with the plasma's alpha waves, producing negative Casimir-like energy. This negative energy is crucial as it counteracts the gravitational collapse and stabilizes a microscopic traversable wormhole throat. Object's position becomes linked across space via this magnetic tunnel, with the plasma ensuring the wormhole remains open long enough for passage. And then lastly, with the wormhole stabilized, the object is teleported, quote unquote, by propelling it through the throat using electromagnetic pulses or by exploiting the wormhole's topology, whereby the entry and exit points are connected as if adjacent in higher dimensional space. That's exactly what it's doing. It's connecting the entry and exit point as if they were adjacent in higher dimensional space, just like this. The magnetic fields tunnel the object's associated fields. So basically saying the magnetic fields enshroud the object, and now we've displaced it from space and time, but all the magnetic fields of the object are still inside that bubble, effectively reconstructing it or transporting it there. Upon arrival, the plasma spheres decouple, releasing the object at the new location while dissipating the wormhole to avoid instability. Wow. That's just from a one-sentence prompt, just asking AI to explain how three plasma orbs can enshroud an object to teleport it through a magnetic wormhole. That's it. It is literally quantum tunneling. It's exactly what we've been describing. Is what they're able to do is they're able to essentially push aside all the 0-point energy, decouple themselves. And once you've done this, you're now in your own little pocket universe. You now can quantum tunnel to a different location. Quantum tunnel. Create a flat space-time wormhole. And now this side of the wormhole is in the Nicobar Islands. This side of the wormhole over here on this side is in the Maldives, wherever your destination orb is. But you must have your 2 points connected. They don't have to be connected physically through an electromagnetic field that we can detect, but they must have some connection. There must be some connection. Create a dipole, like sort of a positive here and a negative here, and they'll naturally attract. Just like when I showed you the pool video. This is the last thing I'll show. This will be our moment of Zen for tonight. The pool video, which is somewhere. Physics girl pool. One sec. Oh, what was it called? Crazy pool vortex. I think that's it. Yeah, there it is. Okay.
Move together. So many questions.
So it's just like these things spinning together. Now, where did she put the... Where's the thing go?
Half ring. They're connected, and that's why they stay together. We can see this if we put a little food coloring into the ends. The food coloring travels from one end to the other, and you can see the entire half ring. So cool. We just made a bubble ring without the bubble.
There it is, chat. That's your moment of zen. Physics girl. Hope you're doing better, physics girl. Shout out to MH370X. I love you guys. We are going to steal all the technology from Lockheed Martin, all the other defense contractors. And we're not just going to steal all the stuff they had that they used on MH370. We're going to steal literally everything that they're working on and everything that they've had out there. And on Friday, we're going to start with Paul Thibodeau's heat conversion of vacuum energy into electricity. Check it out. Don't want to miss it, guys. Thank you, MH370X. Love you guys. Peace out, everybody. Oh, you know what? I just totally forgot. I should do these donations before I do that. Okay, before we do that. Timothy Foster, thank you very much. Timothy Foster, appreciate you. Hey, Ocean, appreciate you. Thank you for that super sticker. Zapparoo, is he? Oh, he's at Michigan State. Of course, he's in the United States somewhere. We can't be. These people can't be allowed to like work for our adversaries. Thank you very much, Zapparoo. Appreciate you. Thank you again. Hey, Ocean, appreciate you. And Mike M, exactly. Dr. 6 Orbs. 4 or 6 Orbs. End of the day, I don't care how many orbs it is, but I will legally change my name to Ashton 6 Orbs if it ends up being 6 Orbs. Peace out, guys. Love you.
Out in the fields where the skies are wide, talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. Wormholes connect distant points in space, traversable paths to a far-off place. No black holes pull, no crushing weight, just a cosmic tunnel to a distant gate.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow.
Exotic matter, negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum squeezed so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow.
Thin shell formalism plates so fine, spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Forces balancing the plate, creating the throat, open the gates, from Earth to the stars in a single bound, a shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead through the cosmic paths that we now tread.
We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow.
From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crunk shines, bringing truth to light. Through his music will explore the night. With wormholes and stargates, our path is clear. Exploring the cosmos.